Hello and welcome to Parabolas. So today will be a fairly quick lesson on introduction to parabolas. So we've done a bunch of parabolas and okay, let's go back to conics. Parabola is basically when you dissect the cone this way. So you're not touching the bottom cone, you're just touching the top cone. So you end up with a shape that goes like that, okay, as you cut it out. Now we've learned parabolas probably starting from sec 2, where we get y equals x squared, and you get this sort of shape, right? We also know that we can get upside down, we can go left, and we can go right by simply negative, positive, x and y flipping them. Today we're going to be using this basic shape and adding it to what we did in physics. Now we looked at parabolas in physics when we looked at light reflection. So when we shine a light straight down into the bottom, which is a vertex of a parabola, it bounces straight back up, right? If we move the light over here, however, it will bounce that way. Same thing over here. It will bounce that way. This, we already figured out from physics class, is the focus or the focal point of the parabola, right? So in physics, we use light rays to figure out the focal point of the parabola. In math, we can use something called the directrix to help us figure that out. Okay, so if we have, let's go through some definitions right now. Okay, terminology. The board's all wet. And I lost my Kleenex box. There. Okay. So if we have a parabola with a focal point there, the vertex there, there exists a line down here that is perpendicular to the line connecting the focal point with the vertex. This line is called the directrix, and its distance is the same distance away from the focal point as it is away from the vertex as it is from the focal point. Okay, that is key. These two are equidistant. Okay, that allows us to do something really cool in mathematics, where if I take any line and I draw it to the parabola, from the focal point to the parabola, and then I drop that line straight down so that it's parallel to this line. If I draw it accurately, this line and this line will be the same length. Obviously mine are not, because my parabola is not accurate to that focal point. Remember, if you shift the focal point around, the shape of the parabola will change. So this focal point is obviously not the focal point for this parabola, because this line is way shorter than this line. If it was the right focal point, it's probably closer down here, I think. Now we're getting closer, right? Or no. How steep it is probably up here. Let's see if I can do that. It's probably way up here. No, but then that's wrong. Anyways, ignore that. Mathematically, what it means is that the focal point to the parabola will be the same length as the parabola to your directrix every single time. Okay. Also, if you draw a line parallel to this line, so parallel to the directrix through the focal point, you get the latus rectum, right? We talked about this with all the other conics as well. Now, what's neat about the latus rectum is that it is the same as this one. So this is 2C to C. So this should be the same as this should be the same as that. Okay, and you can use this to quickly sketch a graph. Okay, again, basics of setting up and graphing and definition. And then the last thing I want to introduce to you today is the concept of a new type of formula. So we know we have 4 possibilities. So those are our 4 possible parabolas. Okay, if we're drawing, we know that this used to be, our equation was y equals x squared. And then we either flip it, actually let's put that here, y equals x squared, and this one was negative y equals x squared, and then this one is simply x equals y squared, and this one is negative x equals y squared. So that's the 4 that we've done probably since Sec 2, maybe Sec 3. We introduce a new type of equation here. We go 4cy equals x squared, and then we have, so this one is negative 4cy equals x squared, and this one is 4cx equals y squared, and then this one is negative 4cx equals y squared. Remember where the c came from? I sort of wrote it down on the last page, but I didn't explain it. C is the length from vertex to focal point. So if you know the distance from the vertex to the focal point, then you can figure out the equation. Then you can graph it if you know the distance there. All right? Let's do a couple quick examples just to get that set into your brain a little bit. As I said, today's lesson is going to be quick because it's basic introduction. I don't want to get into too much mathematics. I'll let the concept sink in, and then we'll do the mathematics tomorrow's class. All right? So if we have, if we're quickly sketching, if I told you that the C is 2 centimeters, right? The focal length is 2 centimeters. How do you sketch it quickly? Well, easiest way is to go for your vertex and then measure 2 centimeters down, and then from there measure up 4 centimeters, and there are your 2 ends because I'm doing my latus rectum, and I have this. All right, so that's the quickest way to sketch, not graph, sketch. Okay, it's rough sketch. So now if we have vertex is at 0, 0, and it goes through point 0, negative 3. How do we figure that out? The focal point. We're not at graphing through a point yet. So if we know that and that, we just play, here's our Persian grid, vertex, negative 3, 1, 2, 3. There's our focal point. Vertex, so we know it goes down. So therefore 3, 1, 2, 3, 6, 6, boom, boom. Okay. And then we have, last example. If the vertex is at 0, 0 again, and we have the directrix is equal to, x equals negative 2. Okay, so if the vertex is 0, 0, directrix is x equals negative 2. So again, quick graph, vertex, x equals negative 2, 1, 2. So this is our directrix. What that tells us that our focal point is up here, and then if we draw our latus rectum, so that's 1, 2, so that's 1, 2, 3, 4, 1, 2, 3, 4, boom, boom. All right, very, very quick introduction. That should be enough to get you going. See you tomorrow.